Hello everyone, and welcome back to another episode of the Internet Computer Developer Journey. My name is Jessie, and in today's episode 1.3, Developing Your First DApp, it's time for us to write and develop our first decentralized application on the internet computer that isn't using the base template provided by DFX. So if you recall, in the previous modules, we took a look at how to deploy the Hello World template that DFX uses automatically when a new project is created. We deployed that to the Motoko playground to get a feel for what creating a new project and deploying it feels like. And then in the last module, Motoko Level 1, we took a look at very briefly editing the default backend canister to provide us with a function that returned a slightly modified hello world string. So instead of just returning hello world, we were able to pass some text to it and return hello and then our inputted text. So up until this point, we've just been focused on the backend canister with some extremely basic functionality. So in today's episode, we're going to be deploying our first DApp that has a front-end UI and also has a complex backend that interacts with that front-end UI. So for today's episode, we're going to be following the written tutorial 1.3, Developing Your First DApp, which can be found by going to the developer docs, going to the tutorial section, and going to the developer journey heading, and going into level 1, module 1.3, Developing Your First DApp. And the link to this tutorial will be in the video description below. So before we get started, we need to make sure that we have our developer environment set up. Now we set this environment up in module 0.3, Developer Environment Setup. So if you haven't followed those prerequisites already, go ahead and pause the video now if you want to follow along and make sure that you follow all of the steps in this guide. Then we're going to jump right into creating a new project. So for this tutorial, I'm going to have the written tutorial here on the left, and I'm going to have VS Code open here on the right. And then I'm going to have a tutorial window that I'm going to open on top of VS Code for the command line interactions that we'll be performing. So to get started, first we need to start DFX. So we're going to use that command DFX start, which we've used a couple times now in our developer journey. And per usual, we're going to use that clean flag to make sure that we aren't accidentally using any previously used cache or local files. And then we're going to use that flag background to send the output of this command into the background so that we don't need to open a secondary terminal window. So we're just going to get DFX started. And then once DFX is started and the local replica has been initialized, which we can see it has based on this output here, we are going to create a new project. But to do that, we're first going to navigate into our developer journey working directory. So we can use the pwd or print working directory command to see where we currently are in the command line. Alternatively, we can also open the Finder on Mac systems, and we can use the Go and then the Home saving. And then we want to use this developer journey subdirectory that we've used in the past. And so if we want to open that in the command line, we can just click and drag it over into the command line. And we can see that full file path there. But in order to navigate into that from the command line, we have to pre-append cd or change directory before that file path and then press enter. Now we can do the print working directory command again and see that we are in this developer journey working directory that has all of our projects. Now we are going to use the DFX new command, and we're going to use the word poll. So this is going to just name our new project poll. So it's going to create a new subdirectory that uses the DFX new template. So remember, that is going to be just a hello world backend canister with a very simple sample front end canister. And so once that gets created, we are going to navigate into that new poll directory, and then we can print that working directory again. And we can see that we are now in that developer journey /poll subdirectory. So recall that by default, DFX is going to create all projects with a backend that uses a Motoko template. If we wanted to use a Rust template, we could pass the Rust flag to that command. But for this tutorial, we will be sticking with the default Motoko template. Now we can take a look at the project's file structure. So there is an output of this with some annotated notes in the tutorial. We can also use the tree command, but the tree command is going to give us a lot more information than we are really looking for from a high level. So we're going to refer to this output in the tutorial, which has been slightly amended to just include the important parts that we want to take note of from that high level. So we have our poll subdirectory, which is the root of our project. We have a default README file that can be edited if we want to publish our project to GitHub and if we want to have a README displayed in that repository. Then we have the dfx.json file. This is the configuration file for our dapp. Then we have two files that are used for the node.js package configuration. We won't be taking a deep dive into these in this tutorial, so just knowing that they exist right now is important. Then we have the source subdirectory. In this, we have two additional subdirectories. We have poll_backend, which is the folder that contains the source code for the dapp's backend. And in that, we have the default main.mo file. So this currently holds that default hello world template. And then we have poll_frontend, which contains the front end configuration and assets for the dapp's user interface. And then lastly, we have a webpack.config.json, and this is the webdapp bundler configuration. So the two canisters that we will be using in this project are the canisters that their files will be stored at source/poll_backend. And so this is going to be the files for the backend canister, and then source/poll_frontend. And this is going to be the source files for the front end canister. And again, so this is by default, it's just going to be the default template that DFX uses. If we in the future want to create a project that does not have a front end, you can pass the no front end flag to the DFX new command. But for this dapp, we do want a front end since we will be creating a front end UI. So now let's get started writing the backend canister code. So if we go over to our VS Code, you can see that I have the developer journey subdirectory already open in the Explorer here, but if you need to open it, you can go to File, Open Folder, and then navigate into your home directory and select that developer journey working directory. And you can see that the poll subdirectory that we just created via the command line is now accessible in VS Code. And so we're going to want to open up the source folder and then that poll_backend folder, and open our default main.mo file. And so this should look familiar since this is the file that we explored in 0.6 Introduction to DFX and also 1.1 exploring a live sample. So first we are going to just delete everything that we have in this because we're going to be writing our own backend code. And if you recall, in the previous module, Motoko Level 1, we talked about actors and how to define an actor. So we're going to define our actor to get started, and we're just going to use that actor keyword and then the curly brackets that will contain our actor's code. So recall that an actor is a process with an encapsulated state. Actors contain both code and data, and they communicate with other actors by sending and receiving messages. And a canister can only contain a single actor. So this is going to define our actor for our backend canister. So by default, this defines an actor, but it does not contain any data or send and receive any messages. And so for this dapp, we are going to be creating a poll that is going to let users go to the poll, interact with a front-end UI that asks them a question. They're going to be able to vote on the question, and then it will display the result of the poll in the UI. So first, we want to define a variable in our actor, and we want it to be the question that we want to ask in our poll. So first, we're going to use the var keyword to define a variable. We're going to use the word question, which is going to be the name of our variable. Then we're going to use a colon and define the type of data that is stored in this variable, which is going to be text. And then we're going to set this variable to be equal to the text string. What is your favorite programming language? And you can see that in VS Code, it's going to go off the screen a little bit here. So for now, I'm just going to close the Explorer on the left so we can see everything without needing to scroll over. And so since we are defining this variable as type text, we do need to import the library for type text from the Motoko base library. So we briefly went over this in the previous module, Motoko level 1, where we imported the debug library from the Motoko base library. So in this example, we're going to import text, and we're going to import it from the Motoko base library, text. So far, we are going to have this program where we import the text library from the Motoko base library. We define an actor, and then we define a variable called question. And I'm just going to indent this for proper syntax. And I did forget a semicolon on the end here. And so now we can see that our actor code and everything looks like in the tutorial. And we can see that our actor has one fixed variable, this variable called question, and it has no methods. So there isn't anything for us to call from this right now. If we were to save this, we wouldn't be able to make a canister call that returned anything of use, since we haven't defined a method. So next we want to define those methods, and we're going to add some access methods. And so, like I said, this is so that we can communicate with not just this canister, but so this canister can communicate with other canisters or other external entities. So specifically for our poll, we want to obtain these goals. So we're going to obtain the current poll question. So we want to obtain this variable question, the value that's stored in it. We want to be able to receive a list of possible options that can be voted on. So in response to this question, what can you select from the poll? What are your choices? Then we also want to allow users to submit a vote on one of those choices, and we want the dapp to save the results so that we can see how one user voted versus a set of other users. And then we also want to provide the functionality to reset the vote counts to be able to rerun the poll. So we can run this with several different user groups, and we don't have to create an entirely different program or canister in order to provide the poll again. We can just reset it from the UI, and we can just keep the canister running as well. We don't need to start and stop the canister. So first we're going to define the getQuestion method. So this is going to be a method that returns the value that's stored in this question variable. So in order to do this, we are going to create a function, and it's going to be a public function, which means it can be called from other canisters or external entities. And it's going to, so we're going to use the word public. Then we're going to use the word query. So this is going to be a query function, meaning it does not alter the state of our canister. It just simply returns information to the caller. So public query, then it's going to be a function. So we're going to use the word func. Then we're going to define the name of this function. We're going to call it getQuestion. And then we are going to have it return a type of async text. And then the actual return that we want for it, we want it to return that variable of question. So this here defines it's a public function. It is a query function. The function's name is getQuestion, and it's going to return a data type of async text. And then the actual return is going to be this question variable. Now we can go ahead and run this code by opening our terminal window. and then using the dfx deploy command. And then we'll see that it is going to create both the backend and the front end canister, which we've only edited the code for the backend canister up until this point. So the front end canister will just be the default that DFX uses when a new project is created. So then we can see that our backend canister has this URL, which is the candid interface. So if we copy this and we open this in a new browser tab, we can see our method of getQuestion, which is defined in our code here. And then we can query it, and then it will return the question of what is your favorite programming language, which is the question that we have defined here. And so if we wanted to change this, we could say what is your least favorite programming language, and we could save the file, and then we can open our terminal again, and we can use DFX deploy to redeploy our canister to apply this change. And then we can see the URL there again, and we can refresh this, and we can query this for the new question. And so to dive deeper into that, this question method is going to take the current value of the question variable and return it to the caller. And there are some important things regarding methods and their behaviors on ICP in order to be aware of, such that all methods that return values need to be declared as async in order to allow asynchronous execution. Since the getQuestion function here doesn't change any data, like I mentioned, it just returns information to the caller. It is declared as a query call instead of an update call. And this method uses the text type that we imported from this base library in our first statement of the program. So to explain a little bit more about query calls, a query call is different from the secondary type of call on ICP known as update calls. So a query call is executed on one node of the subnet, and it is not possible to use query calls to alter data, so query calls cannot be used to alter a canister's code or state. Meanwhile, an update call is executed on all nodes of a subnet, and the result must pass through consensus on the subnet. That's because the update call has the ability to alter the canister's state or code. And in the tutorial here, there is a quick chart that breaks things down further on a more itemized level. You can review that if you'd like, but for this tutorial, we are going to continue on with our code along. And so then next, we need to create a data structure in order to store some data. So since we're going to be storing different poll options, we need to store the number associated with how many votes each option has. So this collection of data is going to be in a key value store. In other languages, this data structure might be known as a directory or a map. In Motoko, this data structure is called an RB tree. So RB trees are used to store keys with their associated values. In this example, we're going to be storing a key of a vote option with the value of its vote count. So the vote option is going to be of type text, and the vote count is going to be of type nat. The text data is for the string and text values, and the nat data is for the numerical number values. So in order to visualize this, the following table can be used to kind of give a visual representation of how a key value store looks. So we can have the ID of the key or the vote option. So here we'll use Motoko, Rust, TypeScript, and Python, and then the value store of the amount of votes that each one of these has as a result of our poll. So in order to use the RB tree data structure, we need to import a few more libraries. We're going to need to import the RB tree library in order to use RB tree. We're also going to be using the nat data types for natural values, so we need to import that library. And then also later in this tutorial, we'll be using the iter library, and we're just going to go ahead and import it now so we don't need to come back to this step later. So we're going to go into the top of our main.mo file, and we're going to import RB tree from the Motoko base library called RB tree. And we're going to import the nat library from the Motoko base library. And then we're also going to import that iter library as well. And we'll elaborate on what that library does later in the tutorial when we use it. So now we need to define the variable that's going to hold our key value data storage structure. So we are going to define this variable as var and then call it votes. And then we want to use the RB tree data structure. So we're going to use RB tree to call the library. Then we're going to, within the library, we want to use RB tree. And then we're going to set up a key value storage of type text, comma, nat, as we just looked at, to reflect this table where we have text for the option and nat for the value associated with that option. And then we are going to use RB tree dot RB tree, and then text dot compare. And so this is going to create that data structure for us. So now that we have this data structure, we need to declare the getVotes method. And so this is going to create a method that queries the amount of votes per option. So it's going to query this data structure to figure out how many of type nat is stored for each type text. And so this is also going to be a query function since we are just calling information from this data structure. So now we are going to define this method as public type query, since it is just returning information, function, and we're going to call this getVotes. And then it's going to return data that is of type async, and then it's going to return that key value store of type text, comma, nat. And then in this function, we are going to use some curly brackets to define what is going to be returned from this function. And this is where we're going to use that iter library, and then we're going to use iter.toArray. And then we're going to call that data structure variable votes, and then we're going to call the entries within that data structure. And we'll close that function with a semicolon. And here you can see that I have a red squiggly line under public, and that's because I forgot to end this line with a semicolon up here. So this function that we've just defined here, it defines the getVotes method, which returns an array. An array is a simple container that's used to store multiple values. So it's used to return that data structure of key value storage. The array is going to return that key value storage in a data type known as a tuple. A tuple is used to store multiple items in a single variable. And so the tuple in this code is of type text, comma, nat, as defined over here. So then this class iter that we imported up here, this is used to represent an iterator, which is a pointer-like data structure that allows for the data structure's values to be parsed one by one in a sequential manner. So this class uses the statement iter.toArray, parentheses votes.entries, which executes the votes.entries method, and then produces an iteration of tuples of type text, comma, nat. that represent the data stored in the RB tree data structure. And here, this iter.toArray portion, this is a standard function that converts the iteration of text, nat from the RB tree data structure into an array of text, nat. And so this step here is important for the front-end canister, so that the front-end canister receives data in the form of an array instead of the form of an iteration. And so now to run this now edited code again, we can make sure that we have it saved, and then we can open our terminal window and use that same dfx deploy command to redeploy our canister with this newly updated code. And then once that canister gets deployed with that new code, we can go into the Candid UI in the web browser over here, and we can refresh it, and now we can see that we have the get question method, and we also have the get votes method. So if we query this right now, we'll see that there isn't anything stored in it, and that's because we haven't created the method that is used to record votes yet. So next, below this, we're going to declare our votes method. And so this is going to be an update call instead of a query call that's used to update the canister state. The reason this method is going to be an update call instead of a query call is because it's going to update the canister state. When the user interacts with the front-end UI, they're going to select in the UI an option to vote on, and when they select submit vote, that button is going to call this votes method and change the data that is stored within the data structure var votes. Since it's going to be updating this data structure, it's going to make an update to the canister state, and therefore it needs to be an update call. This is not just querying information and returning information to the caller. It is making a call to the canister's stored information and making an update to it. So to define this method, we are going to use the word public. And now we aren't going to use that query keyword. We're just going to go right into func. That is because by default, all functions are update calls unless they are defined explicitly as query. So we don't need to explicitly define this as an update call. Then we're going to call this function vote, and we're going to give it an input of entry type text, and it's going to return async and then that tuple value that we just discussed previously that is stored in that data structure. Then we're going to define a variable that checks if an entry already has votes. So if the entry already has a value other than 0, it will need to be returned as such in the UI. So we're going to use the word let and then define votes for entry, and then that's going to be of data type nat for natural numbers. And then we're going to do votes.get entry. And so in the tutorial over here, the code is annotated with a bit more explanation that says if the entry is in RB-tree, then RB-tree returns a number. If entry is not in RB-tree, then RB-tree is going to return a null value for the new entry. And then we're going to end that line with a semicolon. Then we need to be explicit about what we want the code to do if there is a null value or if there is a number value that is returned. So now we're going to do let current votes for entry be data type nat, and we're going to then use a switch function called votes for entry. And so this switch function is going to define two options, and they are going to be defined by the word case. So when this portion of the code gets run, next it's going to go into this and it's going to make a decision based on what the output of this code was. So like the code is annotated here, it can either return a number from arbitrary or it can return a null value. So if it returns a null value, we want it to return the value of 0. But if it returns a number value, we want to keep that number value. So then we will return that nat value. And this nat value is referencing the nat value in the key value store. And then we will close that with a curly bracket and a semicolon. Then we are still in this vote method. So this is the core functionality of the vote feature of our dapp. So now we need to define the piece of code that is going to update that key value store once a selection has been made in the UI. So we're going to use votes.put entry, comma, current votes for entry plus 1. So what this does is it's going to take the user's entry, then it's going to take the current amount of votes for that entry. So for example, if the user is voting on the entry Motoko, and Motoko currently already has 3 votes, it's going to add 1 more vote to that. So this allows that existing amount of votes to just be added to instead of being overridden by the user's vote of just 1. Then lastly, we're going to use that iter library, and we're going to use that toArray function again in order to return this number of votes into an array so that the front end canister can read it and display it properly. So we're going to use votes.entries and close that. And we can see that at some point I got an extra curly bracket since it's red on the bottom here. So we can just go ahead and remove that. And so this is going to be our code so far. In here, we use the question mark nat value. This is a data type in Motoko that is an optional data type in that it may be of type nat or it may be null. If the entry is queried for the arbitrary data structure titled vote, but this entry is not present, it's going to return null. So lastly, we're going to declare the reset votes method. And so this is going to be used to reset the state of each vote option back to 0 without needing to start, stop, or restart our canister. So to do this, we're going to define a function that is going to use an update call again, since this is going to alter the canister state. And we're going to use public func, and then we're going to call it reset votes. And then we're still going to be using that text, comma, nat, data type tuple. And then in this, we're going to be calling the votes data structure, and we are going to update it so that we're going to define Motoko as one of the options with a value of 0. Then we are going to define a second value or second key of Rust with a value of 0. Then we're going to define a third key of TypeScript with a value of 0. And then lastly, we're going to define a key of Python with value 0. And so these are going to be our 4 poll options, and we want all of them to start out with type 0. So these are going to be the 4 key value storage pairs that are stored in our variable votes using the RB tree data structure. And then these values of 0 are going to be altered in this votes function that is going to provide the functionality for these values to be added to. And we can see that my function here is indented one line too early here, so I'm just going to indent that once before so it lines up with our other defined functions properly. And then lastly, we are going to use that iter.toArray function again to once again just update this into an array that the front end is able to read. And we will close everything off with a curly bracket and a semicolon. And so the final code is here in the tutorial if you would like to copy and paste over if you weren't able to code along with us. But so that is the full code there. And so now we are going to save this code. So I'm just using Command S to save in VS Code, or you can just go to the menu and do File, Save. So now we are going to go back into our terminal window, and if you recall, we already started DFX and we are in our pull working directory. So now we can use the DFX deploy command in order to deploy our canisters. So recall that DFX deploy without any other keywords is going to deploy everything in our dfx.json file. So we can take a look at the canisters defined in our dfx.json file by using the cat command. And we can see that we have two canisters defined. We have our backend canister, which uses that main.mo file that we've been editing. And then we also have the front end canister, which we haven't touched yet in this tutorial. So by using this dfx deploy command, it's going to deploy both the front end and the back end canisters, which is fine since in the next steps, we are going to be editing that front end canister. So we want to deploy it. So it's perfectly fine that we deploy both of them using that dfx deploy command. And so we can see that the canisters are being created and built in the background by dfx deploy. And then we can also see some additional backend output, such as the type declarations using candid files have been generated, some other backend pieces. And then once that is all done, we can see that the canisters have been deployed. The front end canister is available in a web browser through this URL, and then the backend canister via Candid is available through this URL. So before we open either of these URLs, we are going to edit our front end code. So for this, we're just going to use some pre-developed front end code. We aren't going to dive deep into writing our own front end code just yet in this tutorial series. So for now, we are just going to copy and paste this HTML code. And there will be links in the video description for some detailed information about building front-end canisters and writing front-end code. But for now, we are just going to open back up our Explorer tab in VS Code. We're going to go to the pull front-end subdirectory, and then we're going to go to the source or src subdirectory, and we have this index.html file. We're going to remove everything that's in this file, and we're going to paste the code that is here in the written tutorial. And you can copy it easily using this little copy button at the top right corner of the code snippet, and then paste it over here. And what this HTML code does is it defines a couple stylistic things. You can see some definitions such as defining the font that it's going to use in the front end, defining things such as heading size and the margin for the heading, defining the background color, the border color. So all of this you can edit and change however you'd like. And then down here, there are just some sample buttons. And so it's a radio type of button that is used to define the 4 options that correspond to our keys in our data structure. So we have Rust, Motoko, TypeScript, and Python. And then there is a submit button to submit our vote. And then at the very bottom, there is a place for the results of the vote to be displayed. So we're going to save this file. So I'm going to do a Command S to save it. And then lastly, we need to update our index.js file. So this is another file that is in this poll_frontend and then the src subdirectory. It's this index.js file. And so in this, we want to replace the content of it with this code over here. So this is going to insert a few declarations that allow the front end to import an interface for the backend canister and seamlessly interact with it. So we are going to insert that into this index.js file. Then next, we're going to be inserting some basic JavaScript that is used to query the backend canister to get the polls question, and then query to get the current vote count for each option. And so we are just going to copy and paste this again, since this is JavaScript and we are focused on Motoko development in this tutorial series, but also going through the development of JavaScript is out of the scope of this tutorial series. So for now, we are just going to copy and paste it. The code is annotated to help describe what is happening, but we won't go through it with the same detail that we've gone through the Motoko code in this tutorial. And then finally, there are a couple other pieces of JavaScript that will need to be inserted into this file. So for simplicity, we are just going to copy this final form of the JavaScript code, and we are, for cohesity, just going to paste the entirety of it. And again, all of this code is annotated with descriptions on what is happening in it, so you can review it further if you'd like, but we will not go into fine-grained detail on this portion of the tutorial. So now we are going to Command S again to save this, and we are going to then redeploy our dapp since we've made some changes to it. So now we are going to just use that dfx deploy command again, and it's going to rerun all of those processes in order to redeploy our canisters with the newly updated front-end canister code. And then we can see our front-end canister is available at this URL. So we are going to copy this and paste it into a web browser. And you can see here is our front end of our poll. So here you can select from the options to answer the question, but you'll see that it just says sample question at the top here. And that's because in our index.html file, in this heading that is known as question, it has just this placeholder text of sample question. So we need to go back and update that and write, what is your favorite programming language? Save it. And then we need to dfx deploy again to apply those changes. Now that that is redeployed, we can refresh the page and we can see that now our question is properly displayed at the top here. And so now we can vote what is our favorite programming language. We can select whatever we would like and we can hit vote. And then we can see the results here at the bottom. So we can see the methods functionalities that we've defined reflected in the UI interactions of our dapp. So when we vote on one of these options, we select vote, and we see that this results down here updates. We can see that this vote method is being used to update the key value store for these options, and the key value store is stored in this RB tree called votes. Then we can see the reset poll functionality by selecting the reset poll button, And then if we refresh the page and make another vote, we can see that Motoko and TypeScript are reset to 0 and Rust now has 1 instead. And we can see that this portion of the code where the current amount of votes for that entry is increased by 1. If we want to vote for Python several times, we can see that that entry gets increased by 1. All the way to 5. And so that will wrap things up for developing your very first full stack application on the internet computer. There will be a link in the video description if you want to fork the entire code for this project, or if you want to clone it and deploy it locally yourself. In the next episode, we will take a look at cycles and how to acquire and use cycles. And then in module 1.5, once we have those cycles, we can deploy this dapp onto the mainnet and serve it at a public canister URL that people can use from around the world in order to vote on your poll. If you enjoyed today's video, be sure to subscribe to the DFINITY YouTube channel to be notified when the next episode of the Developer Journey series is released, and make sure to give this video a like and comment to let us know some feedback on how you enjoyed this video or what we could do better in the future. There will be links in the video description, including a link to the written tutorial that we followed along with today, as well as some other resources on different places that you can go to get assistance or talk to other developers that are also on their developer journey. That'll wrap things up for today. Take care.